In the second half of this video, we will take a look at abstraction in computer science. Chances are you've seen and actually used abstraction while programming before without even realizing it. So let's take a look at where you might have done this before. Regardless of the programming language you first started with, at some point you printed something to the console using a built-in print function. So how is print an abstraction? Well, you as the user have an idea of what the print function does. It prints something to the console. Do you know how the print function is implemented? Likely not. You as the user don't know, nor do you really need to care about exactly how the print function takes your input and outputs it to the console. So, this is an abstraction. As promised, let's come back to our original definition of abstraction. We focus on the ideas rather than the events. Now let's replace the word events with implementation. We focus on the idea rather than the implementation. In other words, knowing what the print function does is enough to successfully use it. As the user, we can ignore the implementation of the function. An essential part of programming is an understanding of abstract data types, also abbreviated as ADTs. You have most likely seen some, perhaps without understanding that they are abstract. Abstract data types are something you will see soon in your programming journey, so this video will not teach you about them in detail. Rather, we will go over a basic abstract data type you may have already seen, so that you are prepared to see new ones. Consider a list. In case you haven't seen lists before, they can be thought of as a sequence of variables grouped together under a single name. So instead of 5 integers, 1, 2, 3, 4, and 5, I could have a list called my numbers, which contains the integers 1 through 5. You probably worked with lists before when learning about loops. So why is the list considered an abstract data type? To understand this, let's take a look at possible ways to create a list with code. The first way is to use an array. An array can be thought of as a really simplified list. It's just a sequence of memory locations where each location holds a single value. The second way is to use a linked list. If you haven't seen a linked list before, not to worry. All you need to know right now is that a linked list happens to be another linear collection of data where each element also has a pointer to the next element. So now we know we can create a list by either implementing an array or a linked list. Now when the user goes to use a list in their code, they have no idea whether the underlying structure of that list is actually an array or a linked list. The best part is, it doesn't actually matter to the user. This is exactly the same as the car brakes example in the previous video, where an array and linked list each represent one of drum brakes or disc brakes. Whether or not the car has disc or drum brakes, it makes no difference for the driver of the car. If you've used lists in a language such as Python before, you'll know that they come with some really useful built-in functions. Min returns the minimum value of the list, max returns the maximum value in the list, and append adds an item to the end of a list, just to name a few. So we've already mentioned how built-in functions in themselves are abstractions. We don't need to understand how they are implemented as users, we just need to know when we want to call the function and how to call the function. The thing that makes abstract data types unique is that they are defined by a set of behaviors. Once more, let's go back to our current version of our definition. Focus on ideas rather than implementation. Now, let's replace the word ideas with behaviors. So we will focus on behaviors rather than implementation. A set of brakes, whether implementing disc brakes or drum brakes, will always behave the same. It will slow down your car when you step on the brake pedal. Likewise, the list ADT will always operate with the same behaviors whether it's implemented with an array or a linked list. In other words, min will always return the minimum value of the list, max will always return the maximum value, and append will always add an item to the back of the list. The difference is only noticeable to you, the programmer who actually implements the abstract data type. Depending on whether you choose to make your list with an array or a linked list, the implementations for these built-in functions will look different. Again, to the user of the list, however, it doesn't matter. Back to the car brakes example, this is like how the mechanic understands the internals of your car's braking system, while you, the driver, do not. So far, calling built-in functions on ADTs has kind of been like this mysterious black box. You know it's there and you know when you need it, but the implementation inside has been largely unknown. The next steps are to open up that box and understand the various implementations of some abstract data types.